Let's move now on copy and write. So if you remember, I mentioned when we were discussing processes and fork that it might look strange when you want to create a new process to actually create a copy of the process that is currently running using fork. But that in practice, there are very efficient ways to do this. And now we are going to have a look at what I meant now that we know what paging and virtual memory is. So copy and write is an example of the benefits you can gain when you decouple what is the logical representation of memory from the physical one. So when you create a copy of a process and you're using the copy and write mechanism, then the new process, the copy of the original process, does not really need to load in memory its own, let's say, set of instructions and data, since they are the same of the initial process, but it can actually share the same space in memory that belongs to the original process, of course, as long as it's only reading that and it's not modifying that. Since we have a page table, we can initially set the address of each page to be actually in the frame that belongs to the other process. If we are only going to read those pages, then it's perfectly fine. Actually, in fact, all the pages that are there only to be read and not written, we can keep using the ones of the original process. What we need to do is that whenever one of the two processes tries to modify a page, since now these modifications do not need to be observed by both the parent and the child, not only they should not be observed by both, then in that case, we can throw a page fault and load again the page, but a copy of it for the process that wants to modify it, okay? And you have variations of fork that you can use actually to use the copy and write mechanism. So it looks like this. If process 2 is created by forking process 1, each one will have its own page table in a different portion of memory, but the content of the page table, so the addresses of the frames, can be the same for the two of them, okay? We have 3 pages here, so they are both pointing to the same page. That's why creating a process through fork is extremely fast, because in fact, you don't really need to load anything into memory. You just have to create, of course, a new page table, the process control block of the new process, but when it comes to the information that belongs to the process in memory, you can just keep using the one of the parent process. If process 1, let's say, wants to modify a certain page, page C, then in that case, you create a copy of it. This is just a slide I put here since a couple of years to give you an indication that, of course, what we discuss in this course, it's not only basics of computer science, but it's also something that is active, an active field of research. Here you have an example that comes from security. So I'm not going into details here, but turns out that there was a bug in the implementation of the copy and write mechanism, and that could be exploited to gain access to parts of memory that should not have been granted access. And this thing was there, the bug, since 2007, and you see that it was like more than 9 years after that it was discovered, and this was 4 years ago. So this is just to give an indication that these things we are discussing right now, they are also part of research.